Hello and welcome to another creative coding video. In today's video we're going to look at the same idea that we looked at last time, but in a much simpler way with a much simpler example, just to help us understand it better. Okay, so on the screen we've got a pattern of circles, and we can see here there are 1, 2, 3, 4 circles. Actually, we could have had even more, but just for the purposes of this example, there's 4. Now, how do we write code to draw this pattern? Now, you could say, easy peasy, there's 4 circles, we can write 4 circle instructions, and that's it, job done, and you're probably right. But if we had 40 circles, or 400 circles, or maybe even 7,000 circles, then we wouldn't want to do that. We'd want to use the repeat instruction. Now, when we are thinking about writing efficient code, one of the first things we should try and do is to look at the design that we're trying to create and see if we can spot any commonalities or patterns. And the reason we should do that is because those commonalities and patterns can be an advantage to us. We can take advantage of them when we're writing code. That sounds a bit abstract, so we'll see that in action. So let's have a look at this pattern. What's the first thing that we see? Well, all those shapes are circles. That sounds a bit trivial, but it is actually helpful. It means our code can just draw circles. We don't have to have a special case for drawing squares or triangles. So that's the first thing that we kind of bank, as it were. Great. What's the next thing that we notice? Well, I've noticed that all the circles are in the middle of the canvas. They all have their centre spot on the middle of the canvas. So the middle of the canvas is here. So the canvas is 800 across and 600 down, which means that the very centre is 400 across and 300 down. So those are the coordinates of the centre of any of those circles. In fact, all of those circles have that as the centre. That's a nice thing to notice. Again, we can take advantage of that in our code. Great. What else do we notice? Well, I'm seeing that the circles seem to be getting larger in a regular, uniform way. Let's see if that is the case. How big is the smallest circle? Well, it goes from here to here. How big is that? What's the diameter of that circle? Well, it goes from 350 all the way up to 450. So its size is from there to there, from there to there, which is 100. Its diameter is 100. The next one goes from here to here. That's 300 to 500, so that size 200. And the next one goes from here to here, and that's size 300. And the next one is from here all the way up to there. That's size 400. There is a pattern there, isn't there? Each of these is going up in steps of 100. That's the pattern. That's useful. We can take advantage of that. Okay, let's start coding. We'll make a start, see how far we get. Let's go through the thinking process. So I'm logged into Open Processing as usual, and as usual I've set up the simple.js instruction, the library. I've enabled that, and I've got simple all set up in the setup section there. It's what we always do when we start coding. Okay, and in here in draw, this is where we write our instructions that are carried out by the computer. Now we know that we're going to have to use repeat in some form or other because we want to draw lots of circles. Remember we said we're thinking that we might have more than 4 circles, we might have 40 or 400, so we have to kind of keep that in mind when we code. Okay, well, let's write down the repeat instruction that we have used in the early videos, and that instruction had 2 bits of information inside the brackets. It had the number of times that we wanted to repeat some instructions and the name of the function that we wanted to repeat. Let's call ours my ring because we're drawing rings, aren't we? So just as a reminder, the repeat instruction will repeat my ring 4 times. Great. And we now just need to write that function to describe what it does. And let's, just to get going, let's write a circle instruction and then think, well, what does it look like? Well, the circles were all centered at 400, 300, so we can put that in. Circle 400, 300, we'll draw a circle in the middle of the canvas. What size should it be? This is where it gets interesting. Well, let's not stay stuck on this question. Let's just put in a number, let's say a size of 100. If we ran this code, what would happen? Well, let's work through it. The draw function is run, and it expects inside it our instructions. We've written repeat my ring 4 times, which means this my ring function gets run 4 times, which means this instruction gets run 4 times. And that means a circle is drawn 4 times at location 400, 300, size 100. Maybe that'll draw the circle on top of each other, the circle, so we'll only see one circle because there are 4 circles of exactly the same location and size drawn on top of each other 4 times. That's why it looks like there's only one circle, but it's actually the same one drawn 4 times. Well, we're halfway there, aren't we? What can we do? Well, before we carry on, I'm just going to make some style changes. So I'm going to say no fill. That means don't fill the circle. Just tidying that up a bit there. And I'm going to change the thickness of the circle, of the outline. Let's say size 4. In fact, I don't need to repeat that 4 times. That can be here. Let me explain why I've done that. This instruction is making sure that these shapes that we draw don't have any fill, that they're see-through, so they're no longer filled with yellow. This changes the thickness of the outline of a shape and makes it bigger than the normal size of 2. I'm going to give it a size of 4. So the thickness of the outlines is now 4. And we don't need to repeat that 4 times inside this myRing function. We only need to do that once. That's why I've put it here and not inside there. It wouldn't make a huge difference, but it's just more efficient. Actually, let's just see the effect of that. There you go. An empty circle, no fill, thick outline. Great. Now let's get back to the task at hand. We got distracted there by a bit of styling. Okay. What would help us? Let's go back to our sketch here, our pen and paper style drawing. Well, each of those circles is growing larger. Wouldn't it be nice if we could somehow keep track of the sizes? So 100, 200, 300, 400. If only we had some kind of counter that started at 100, went to 200, went to 300, went to 400. If we had some kind of counter that could do that, that would be helpful, wouldn't it? Well, in fact, the repeat instruction does allow us to do that. Let's have a look at this new use of the repeat instruction. There it is. There's a lot going on that picture. Don't worry, we'll break it down. So at the top you can see there's a repeat instruction. We're familiar with that. There's a function that we repeat. This one's called do something. Our own one in our code is called myRing. Now here we've got lots of numbers. Let's see what's at the bottom of the screen. We've got a definition of that function, do something, and we can write code in here that's repeated, that defines what the function does. That's all stuff we've done before, except these new numbers. So what does this mean? Does it mean this is repeated 100 times? Or 300 times? Or 50 times? Nope. These numbers define how a counter behaves. So what it means is this repeat instruction starts a count at 100. It goes all the way up to 300 in steps of 50. So the first time this do something function is called, that counter is 100. The next time it's called, it's 150. The next time it's called, it's 200. The next time it's called, it's 250. The next time it's called, it's 300. So that's what we want. We want a counter that starts at a number that we want, like 100, goes up to a maximum in steps of 50 here. So that's great. That means this do something is going to be called 1, 2, 3, 4, 5 times. So instead of saying repeat 5, we're saying repeat with a counter that starts at 100, goes up to 300 in steps of 50. That's great. There's something else going on here. Inside this brackets, inside these brackets, we've got an X. Let's go back to our code that we're used to. Can you see here? We've not got any number there. In fact, all of our functions have not had any number inside the brackets, or anything actually. What's going on? What's going on is this repeat instruction is passing the value of the counter, the number, to our function, and our function is expecting it now. It's saying, I'm expecting to be passed a value and I'm going to call it x. So we could have called this something else. We could have called it counter, we could have called it the letter C for counter, we could have called it A or B or C. I've just called it x here. And inside our code we can use that x. So the first time this is called, it's passed the value of 100, so x is 100 in here. The next time it's called, that x is 150, and the next time it's called, that x is 200, and so on, up to the last time where x is 300. So you can see that could be useful, couldn't it? Now we don't have to make use of that value, we don't have to use that number, we can just take it and then do nothing with it. But I think it's going to help us because our circle sizes are growing in steps, in regular steps. So let's go back to our drawing. If we had a repeat instruction with a loop counter, we would want our counter to start at 100, go all the way up to 400 in steps of 100. My ring, and that's what our repeat instruction would look like. Repeat, a counter starting at 100, going up to 400 in steps of 100, and pass that counter to my ring. That makes sense now, doesn't it? It's all coming together. So let's change our repeat instruction. So we're starting a count at 100, we're going all the way up to 400 in steps of 100, and my ring now has to be changed to accept that counter. Let's call it, I don't know, could call it X. Let's call it S for size. And we're drawing a circle at 400, 300 and size S. Let's say that again, because this is new code and it's worth just talking about it one more time so we really do understand it. The repeat instruction will start a counter at 100, keep increasing it by 100 until it gets to 400. And with each of those values, it's going to call my ring and pass that counter to that my ring function. And we receive it and call it S. And we use it when we draw a circle, we use it as the size. Let's see what happens when we run the code. Ta-da! That worked. Magic. Fabulous. Fantastic. The first circle there, size 100, 200, 300, 400. That's rather cool. Now, what do you think would happen if we went up in steps of 50? Well, we'd start at 100 and we know that we're going to go up to 400, don't we? So that the last value will be 400 and we're going up in steps of 50. That means the next one will be 150, then 200, then 250, then 300, then 350. So we're still starting at 100 and we're ending at 400, just like before. But now we're going up in smaller steps. So we're going to be calling my ring 1, 2, 3, 4, 5, 6, 7 times. So we'll be drawing more circles, and because they're going up in smaller steps, the size, they'll be closer to each other, those rings, more tightly packed. Let's see it in action, it's easiest to see it. So 100 to 400 going up in 50. There you go, that's rather cool, isn't it? Do you see how powerful that is? Now I know we've done a lot of talking and a lot of sort of explanation and chit chat, but it was worth it to get to this point with very simple code. I mean, let's just look at the code. That's it. That's rather impressive, I think. Quite an interesting pattern with such a small amount of code. The effort was in recognizing the pattern, the regularities, the commonalities in that design, the fact that they were all circles, the fact that they all were centered in the middle of the canvas, and the fact, the most important point, the fact that each of the circles had a size that grew in regular steps. That's rather nice, isn't it? Now I'm going to do what we did in that video last time, which is, and I encourage you all to do it, which is to think what else we can use this loop counter for. So at the moment, this loop counter is being used for the size, but we don't have to use it for the size. We could do something else with it. Maybe I'll use it to colour the rings. So it's not the fill command for choosing a colour, because that sets the inside of a shape. Stroke is the instruction for setting the colour of the outline, and we're going to use the red, green, blue way of mixing colours. If you need a reminder, do go back and have a look. So we can choose 3 numbers which can go up to 255. The red part, the green part, and the blue part. Let's just experiment now. What if I said this was size, the red green part was S, and this one was 255 minus S, minus the size. Let's just see what happens. Now before we do run the code, let's have a think. S will go from 100 to 400, and it will be going up 100, 150, 200, 250 and so on, which means the red, green, blue, the green part will be growing. The first one will be 100, then 150, then 200, and this one, the red part, will be getting smaller because it's 255 minus 100, then 255 minus 150, and so on. Let's see the effect. I can't wait to see it. I've chatted enough. Oh, isn't that nice? That is really cool. And again, I'm quite, I'm always amazed, even though I've done this for quite a while, I'm always amazed how really simple code, which admittedly has had a bit of thought put into it, simple code can produce such interesting effects. That's a really nice design, I think. And yet we managed to get that colour effect with just one line of code. Let's experiment again. Let's say we choose to half the S before we use it. Let's see the effect there. That's really rather nice as well. I like that. Let's try another experiment. Let's just say we're dividing that one by 4 and we're making this one half of what it could be. I'm going to make those rings a bit bigger. Let's see what effect that has. You should just experiment yourselves. I'm just messing around here. Wow, I really like that. That really works for me. Yep, So you should definitely have a play yourselves. It's a lot of fun. So yeah, just to recap, we've used a new way of using repeat, and this time, instead of just repeating a function, 3 times, 5 times, 10 times, this time we're using a counter which starts at a number, goes up to another number in steps of a certain size, and for each of those counter values we call our function and we pass the counter to that function, and we can use that number. We don't have to, but it's useful, and as you've seen, we can do some really cool things with it. The first thing we did was use it for the circle size, but it was a lot of fun using that counter to pick a colour. I thought that was really rather cool. I've noticed actually when I'm working with friends that sometimes they miss out this bit here. They use the brackets without anything in there, and that doesn't work because this function as it is now isn't expecting to be passed any information, but with this it is expecting one bit of information, and we happen to call it S. We could call it something else. In fact, let's illustrate that. Let's call it X, which means every time we use it, we use X. We have to be consistent like that, and that produces the same result. Fantastic. Well, I hope that's been useful. I hope that's illustrated the loop counter idea in a different way and help the idea sink in. The best thing you can do if you're still not fully comfortable with it is just experiment. Take that code, the one we've just developed, and mess around with it, and as you experiment and play, using it and also making it fail will help form the idea of how it works, and that's a really valid and a good way of learning to code. Fantastic. Well, I hope you had as much fun as I have had, and we'll see you next time. Bye.